Some kids, because you know they come in and
I know what you mean.
And then they just you pretty much say no. But
you have to say no, otherwise you can take them.
Yeah,
so
otherwise
you have to say
good.
you don't. Huh.
Yeah.
Your parents have to sign.
So if I say I don't and then you still
don't
do
have
it,
to
you
give
get
you
in
an
trouble.
option to do that, like a form.
I don't. At Votech, I know they hand out forms, and if somebody does feel that way, they hand them in.
Anyway. We're not. I was just joking. I'm not gonna.
I know, but
unless you want to be recorded,
I don't mind being recorded.
throw it up on
I'm
the
sure Rob doesn't
YouTube
mind.
channel.
She used to record everything.
I'm probably not gonna. Go ahead, put it on the YouTubes.
On the YouTubes. All right. So here's the deal. Moving left to right. So if we start all the way over here in group 1, let's say we're starting here on K, and we start to go. Okay, imagine you're actually standing there, and you start walking this way until you end up at KR. What happens to what's called the metallic character? Don't say it, just think. If you don't really have an idea of what that means, I'll summarize it or I'll simplify it. Instead of metallic character, what does that mean? It means how much it acts like a metal. That's what metallic character means. How much does it act like a metal? So that's moving left to right. Think about what happens as you move left to right. And then the second part here is if we're, let's say, at lithium. No, over here. Over look to the right. Let's say we are carbon. And we move down this group. So we start at carbon and we move down this group. What happens to the metallic character? How much does it act like a metal as we move down the group? So I'm going to give you another, 20 seconds. Think about it. Think about it. So in the blank, it's either going to be increase or decrease.
Yeah.
That's really important. Increase or decrease is what we're looking for. I'll give you 15 more seconds to think about it, and I'll call somebody.
Nah, I got 0.
Boy, something's going to be important.
So these are going to be elements. All right. Anybody have an idea? Go ahead.
Decreases for the first one.
So Brody says as we go left to right, the metallic character decreases. All right. You have an idea about the second one there?
Oh, it increases.
You said increase? So as we move down groups, so from the top to the bottom, it increases. All right, interesting. Who agrees with him in the first thing? Metallic character decreases as we go left to right. Okay, Brody, you have some supporters. Now explain why you think that. No, and Robbie.
It goes to
Yes, it does the girls.
to noble gases,
Which are not metals.
Yeah, exactly.
Exactly. You are 100% correct. Good job. Everyone else who had it, good job.
Okay, Brody.
Here's the logic. Here's the logic. K is a very, very reactive metal. We already said that. These are the most reactive. As we move away from it, they become less reactive, and actually you start turning into non-metals. So if you're moving from a metal towards a non-metal, you're going to become less metallic. So metallic character decreases. So the properties of the metals in chemistry, we'll say, because it's confusing, because if you move left to right, look at this, look at the metals that we're hitting here. Chromium, manganese, iron, cobalt, nickel, copper, zinc. Iron, cobalt, nickel, copper, zinc. We use those, a lot of different industries use those, okay? Plumbing, construction, probably welding uses a lot of that. So, I mean, that's a lot of metals we use. So a lot of you might say, well, those are really good metals. Different, it's different. We're talking about reactivity.
They're not reactive, that's why.
Right, exactly. That's why a lot of pipes are made out of copper. Not very reactive, okay? And you might know, does anyone know if you galvanize like a steel nail, let's say? What's that? Yeah, what they coat the steel with? It's zinc. Look where zinc is. Okay? So if you have a galvanized nail and a nail that isn't galvanized, and you leave them out in the elements for a long time, the one that's coated in zinc, the galvanized one, okay, zinc, not very reactive, will last a lot, won't oxidize, won't rust anywhere near as fast as the one that isn't. That's why we use it, Rob. It's a good point. That's why we use them. So the metallic character decreases as we move left to right because of what we said earlier. The most reactive are on the left. All right, and then moving down, metallic character increases. Brody is correct, but let's explain why. Let's look at group 14. All right, group 14. Devin, is carbon a metal, a non-metal, or a metalloid? And if you don't remember, that's okay, because you haven't been here in a while.
Metal.
Try again.
Non-metal.
Good job. See the staircase here? There's a little orange one, and in your reference tables, it's like bold.
Yeah.
Yeah. To the left of it, Jeff, what's to the left again?
Oh man, come on now. You keep doing this to me.
I know, I feel like you're zoning out.
Because I am. Metal.
There you go. Yes! Metals to the left, non-metals to the right. So Jeff, you with me now?
I'll try to be, yeah, sure.
Okay, what's going on today?
I just want to doodle, man. It's Monday. You
I
know?
get it, but I need you to pay attention to me. I'd like to sit and doodle too. But,
Go ahead. I ain't telling you what to
granted,
do.
this is my job, but this is your job, right? So
No,
carbon.
I have a job.
Well, you know what I mean. So carbon right here, Jeff, is a non-metal. Why is that again?
Because it's not made of metal.
Correct. I'll take it. It's to the right side of the staircase. That's why it has non-metal properties. We're going to list those today. Now, if we move down, Si, who knows what that is? Yeah, but I mean, what type? Metal, non-metal?
Not metal.
No.
Metalloid. Okay. So what's a metalloid? It's kind of in between metal, non-metal. What about GE? Metalloid. What about SN? Metal, lead. So, I'm explaining why if you move down a group, it becomes more metallic. If you go up the group, you're actually a non-metal. But you know what? These trends, that's called a trend as you progress down a group or period, a trend, they affect the entire periodic table. So let's use our brains here. If you move left, you become very non-metallic. But if you move down, you become very metallic. Let me say that again. If you move left, I think I said it wrong, sorry. If you move left to right, if you go right, you become non-metallic. But if you go down, you become metallic.
So would that make francium super metallic?
Ding, ding, ding. You win the gold star. Francium is the super metal. Very good. So, francium down here, this corner is the most metallic out of everybody on the periodic table. So, without saying it out loud, think, which element is the most non-metallic? If this corner down here is the most metallic, which corner do you think is the most non-metallic? Kelly Jo?
Is it helium?
Close. You're thinking too hard.
Is it?
Remember, what's wrong with these guys here, number 18? They're noble gases, but what don't they do?
Oh, they don't react.
They don't react because they're stable.
So is it fluorine?
Yes, very good. It's the two F's.
Non-reactive.
Francium and fluorine. Those are the two that are the most reactive. So, you know, I teach this lesson the same way I teach AP Chem, just to let you know that it's really important, and I teach all my classes the same thing, to understand this corner is the most metallic, that corner is the most non-metallic. So a lot of the stuff, and I've said this earlier in the year, a lot of stuff we learn, it's the same as I teach all the way up to AP Chem. Okay, we just might move a little slower, but this is kind of really important to remember throughout the year, because I use this a lot to explain things. So most metallic down here, most non-metallic up in the top right. So they're like kitty corner. You know anyone who says catty corner? Doesn't that sound just weird?
Who?
You've never heard anyone say catty corner?
I've never even heard
Liars.
What's a kitty corner?
Kitty corner, you know what kitty corner is?
I don't even
Ah.
Who's never heard of kitty corner?
Who should know?
Who's heard of kitty corner?
I'm not gonna. If you don't throw it out.
I've heard.
Kitty corner is like diagonal. No? Nothing? What's going on?
He was trying to throw something out, and Brody.
Hey, while you're standing, you just want to read your article real quick?
Yeah.
Real funny.
Anyways, they're diagonal. That's what kitty corner means, diagonal from each other. Okay? Alright. Now,
Wait, so what's catty corner?
same thing as kitty corner. It's just depending on where you live in the country. It's kind of like people on Long Island. Anyone know anybody from Long Island?
Yeah.
What do they call subs?
Oh yeah, I do. Oh,
It's like
What?
Hobie.
Hoagie, right? Hoagie. Or I've heard people from down near the city call them heroes.
It's like, yeah.
Why?
But I call them stuff.
So
Same thing as catty corn or kitty corn.
You know why they call them vice grips?
It's just
What's a vice grip?
Y'all-
Oh, you mean the actual vice grip? No.
That's the name of the company that makes them. They don't call them that.
Kind of like Kleenex.
Yeah.
Like that's. Is that Kleenex? No, it's Puffs.
No.
But we all say Kleenex. Yeah. Actually, I say tissue, but some people say Kleenex.
That's it.
Yeah, I say tissue. I mean, come on. This is America after all, you know? Not like we're drinking our tea, we're actually drinking coffee.
I don't know what that means. But
I don't either.
you're saying we're not from England? What are you saying?
I'm saying I'm not from England. I was born in this country.
Yeah, that's right. All right. So here we go. Let's do this. Let's categorize metals and non-metals. Let's categorize, not categorize. Let's list their properties. Okay. So let me give you some examples. All right. So here we go. We got two pieces of metal. Okay. We got copper. We got aluminum. All right. Do something with that, Dan. Show me a property. There you go. Good job, Dan. Dan bent it. Okay. You bent the metal. So strong. There we go. Okay. Can you bend it back? Go ahead. I'll hold that side. You hold that side. We bend it together. Here we go. Okay.
Teamwork.
There we go. So metals can bend, but there's a special word for that. Guess what can't bend?
Non-metal?
Non-metals. And this,
Oh, it's so pretty.
what is this?
Silicone.
Yeah, silicon.
Let's
Okay,
start with
it's silicon. What does it have in common with this metal?
Shiny.
All shiny, good. What happens if I try and bend this? It'll break,
Break.
right? It'll break, right? Okay. Now this is a metalloid. This is a metalloid. Okay. Non-metal.
I want it.
I don't feel like taking this out, but this is a non-metal.
What is
They're like powder.
What's it look like? Something in real life.
That's the name you see.
Gunpowder.
Gunpowder, okay, close.
What's that game? Kind
You
of
know what they are
like
not, but
crushed
it's
up
the game
charcoal.
they use to etch a sketch. No, it's the
A little bit.
Oh yeah, with the magnet and you build the mustache.
Oh my
I don't know what it's called, but yeah.
Yeah.
You have a magnet and you
Wait, wait, it's coming to me.
You know what I mean?
Yes.
I don't know what it's called.
Isn't it
but
like
it's
somebody's
amazing.
name? Yeah, it's
like-
Mister. It's Mister something, isn't it?
But they had it when I was
I got nothing. Yeah, how do you know about that?
Mister. What?
I
I don't know. I've seen them. I've played with one. I don't know. I just remember it.
I was trying to get at, this kind of looks like soot to me.
Really?
Yeah.
Ooh, probably not.
Because this is, that's what it is, charcoal.
It's jet black.
This is carbon, charcoal.
Oh, that's
so,
what reminds you of soot.
Right.
That's just cheap though.
So this is this is
That's
carbon,
something else.
and carbon is a non-metal. I don't want to take it out of here. It's like a powder. Obviously, a powder can't be bent. Okay, is this shiny? No, not compared to this, right? So non-metals definitely not shiny. They can't bend. Let's see, what else do I have over here? Oh, I have it on my desk. Okay, this is another type of metal. This is tin. Okay, tin. It's kind of shiny. Has a little like gold hue to it. It's not gold, obviously. It's tin. Which one is tin up there?
SI. No.
SN, right? 50. So that's a metal. So it's hard, right? You can hear it clanking in there. It's shiny. Let's see. What else do I have here? Oh, this one's cool. This is gallium. This one melts in your hand.
Oh, it's so cool.
Oh, yeah.
But
Can you do it?
Can we do it?
Come on.
Does anybody want to try?
Yes, I do.
Who wants to try?
I do.
Everybody. I want to have
Yeah,
it.
everybody
but
wants to
you're
try.
gonna have to like share gloves.
Well, oh well.
Can we get put on bare hands?
No,
Why? What happened?
because it can stain your
Both
skin.
of them?
Yeah, you gotta
My
put both
skin
on.
falls off every day. Why both?
Because you might have to kind of warm it up. One hand might not work.
You could definitely close it with one. Probably.
Yeah, if it's no, I'm trying to, close that. Because
If it gets like.
it might drip on it. I don't know. We'll see. It drops on the floor. This works with your hand very easily, but with the glove, I don't know. If you guys want to come over, you can.
Oh, geez, what's the invite?
How much does he charge? I don't even know how much.
Yeah, that's so pretty looking.
The gloves might insulate it enough. Because the reason it's in a weird shape like that.
Push it down right on his hand.
Just kind of
Yeah, I can feel it starting to.
Oh, it's a,
cap is on though.
Good job.
It's so hot up in here.
I'm not gonna stop.
I'm fine.
You want to, but at the same time,
It's kind of.
Oh yeah, there you go. Starting to get a little gooey.
It's so pretty.
So why is it melting so easily?
Because it's hot.
Yeah, but if you were doing that with a piece of iron, it wouldn't melt.
because of what it's made of, it reacts.
Well, this is gallium. It's not necessarily. Let's not use the word react, but ice cubes melt right in your hand. Okay, most metals don't. This metal does. What does that say about this metal?
Particles spread out.
How about use one of the words either it's weak or it's strong.
Definitely not strong metal.
Let's see.
I wouldn't wear that. Oh.
Ooh, look at your other glove. Like your other glove has like.
Whoa.
Yeah, that's why you don't let it touch your skin.
Yeah.
Wow.
Oh, wait, is that on your hand now?
Let me see it.
It shouldn't be.
No?
It should be
Let
on
me
the
see the
glove.
glove.
Well, it's like black under. Or is that?
It's not really.
What's up?
It's like.
Yeah, but it's soft.
The thing is, it's soft. Yeah. Yeah.
That's cool.
Put her back in there.
That's crazy.
So does it solidifies it back up?
Yeah, we'll just check the files. So, oh, got a piece. Someone else wants to try.
Wow, the science.
Give Roberto a try.
I'll try.
Oh.
Now
Let me wipe it with the paper towel. Yeah, because you don't want to get, it's technically metal poisoning.
Really?
Yeah, because it'll absorb through your skin.
Is it true if you eat enough nickels, you'll go blind?
I'm gonna say yes.
Yeah.
I mean, if you don't go blind, something bad will happen.
Who eats nickels?
Yeah, I mean, you mean like a nickel, like
Or maybe it was dime poisoning. I don't know. Some guy tried.
Dime
Why are you
poisoning?
eating?
Yeah.
Is dime poisoning a thing?
I don't know. People are dumb enough.
What are dime poisoning?
Oh
If you eat coins, it's not gonna be good for you, period. It's the coin. You're gonna have to.
You gotta dab paper towel or something. It's like,
A little good. I saw a little petting.
They gotta make sure it pass because if it doesn't
kind of.
cause a lot of problems.
I got all.
What if it gets stuck in them? Well, like, what if you try to pee it out?
I'll get that later. All right. Let's list some properties there. Yeah, I wanted to show you iodine today. We're not going to get to it probably, but let's list some properties. So, metals can bend, right? Does anyone know the fancy word for that? Starts with an M.
Valuable.
Malleable.
Wow, that's fancy.
Metals are malleable, and what that means, it can be flattened into sheets. Flattened into sheets. The other word makes me think of Play-Doh. Who's tasted Play-Doh?
I have. It's like
Super
salty.
salty, yeah.
Yeah.
I mean, I've never tasted it.
Yeah.
So, you guys remember when you were little kids, maybe you had this, maybe you didn't. The thing with Play-Doh,
I didn't even try a bouncy ball. I used to
you push the Play-Doh through and then it comes out the side like spaghetti.
Yeah, and then it's like, yay, spaghetti, and you
Right,
eat it.
and then you eat it. It tastes like salt.
It's like, oh, this
It
is
tastes
salty.
like crap, right. So the concept there is the spaghetti. You can do the same thing with metal. What? What's that called when you make
You can.
big hunks of metal into tiny thin strips? And then you can
Spaghetti.
put them in your walls so electricity
It's called
flows
making
through.
wire.
Right, making wire. It's a very similar process actually, except you have to heat the metal up. Why? Softens a little bit, right? So it's more pliable, right? So that's called, you may not know this, I'll give it to you, ductile. Ductile is the ability to be formed into wires. Formed into
I feel
wires.
like I've heard that word before.
I think you heard duct tape.
Formed into wires.
No.
Okay, metals are also shiny. What's the earth science word for that? Starts with an L.
Luster.
Luster. So metals have luster. You can say shiny if you want, but in general, metals are hard in general, right? Some of them are softer. We just saw one that's a little softer. Mercury's a liquid.
So, if you freeze it, will it become like mercury? Like if you freeze mercury,
If you-
will it solid? So it's
So
fine.
if you get it cold enough, yes.
You can
Our freezers wouldn't be cold enough.
You can make anything a liquid or a gas, right?
If you have enough heat and or cold, well, absence of heat and or pressure or not pressure.
Wait, could you
So,
freeze acid?
Freeze acid?
Like a solid block of acid?
I suppose so. That's tricky because a lot of acids are gases in their pure state. I guess you could. I guess. Yeah.
What would happen if you were to touch that solid block of acid?
It would probably burn, but slower.
Oh, okay.
Metals can do this. I just explained it. You put wires in your wall, so when you flip on the switch, conduct what? Electricity and heat, right? Frying pans. So they conduct electricity and heat. And I'm just going to give one more here. It's mostly solids, right? There's only one liquid metal, but mostly solids. Oh, let me look at my notes. I do a lot of stuff top of my head here. Good, good, good. Okay. All right, non-metals. So if I hit non-metals with if I hit this thing with a hammer, what's it going to do? Break. Now that's a metalloid. Non-metals are brittle. Okay. Think of a briquette or charcoal. You know, a piece of charcoal. You hit that, that'll break. Non-metals do not conduct. You guys all good?
No, I haven't got much.
What do you have study hall next, right?
No, I have gym. I don't care. I'm in gym.
Well,
Take it during
you should have time.
For your ID.
We're almost done. You can go right at the end of class.
I am not gonna.
Okay, so stay with me. Brittle, do not conduct. Let's see, what else here? Let's see, I'm losing my mind here. Oh, they're dull. They're basically all the opposites of metals, right? Mostly liquids and gases. Liquids, gases. There are some solids too. We'll say some solids. Non-metals are weaker. I'll explain what that means down the road. Non-metals are weaker, metals are stronger. And by the way, the gallium that Tristan was holding, this is a weaker metal because it melts very easily. If something melts easily, like wax, it means it's weak. We'll talk more down the road what that means.
Couldn't pull the car out.
What's that?
It's metal, but you still couldn't pull the car out.
Correct. It would not work so well. As soon as it got warm enough, it would just melt.
Shouldn't the seat melt through it?
Yeah, basically. Okay. That's it. Those are the properties for metals and non-metals. Okay, last thing. I don't know if I have time. Let me give you the worksheet. I want to make sure you have time for that. So worksheet due tomorrow. Miss Miletto's favorite. You got questions on one side,
Awesome.
table on the other side.
We love to flip.
We love to flip.
I don't. You see, I like two things stapled together. You can rip them right apart. No flipping.
Side by side, right?
No energy burnt off unnecessarily. Good one.
Alright, so I'll have your article tomorrow.
Wait,
It only
it's the
says
same
date in
thing?
class. It doesn't even say
Mr.
name.
McCoy.
Alright, so the ones that are circled mean nothing. Do all of them. Okay, 1 through 12. Do them all. Do them all.
I
Okay?
thought that meant just through these.
No, do them all. Hold on 1 second. So, I just want to make sure you understand. If you have two elements that are in, where's my thing? Two elements in the same group. Look up here. I put both of these in water last week. How did they both react?
Explosion.
Explosively, right? Lots of fire. They pop, sizzle.
Violent.
Why? Because they're in the same group. You're gonna need to remember that for that worksheet. Okay? Remember that. All right. You can go, Kelly Jo.
Bye, Kelly. Get out.
Everyone else have a good day.
Don't tell me what you do.
All right.
Now I'm gonna tell you.